Welcome back to Physics Forum. So in the previous lecture we have already seen how to calculate center of mass of continuous body having surface mass density such as semicircular disk and hemi-hollow sphere. In this particular video we are going to discuss calculation of center of mass of continuous body having volume mass density such as hemi-solid sphere and solid cone. So let's see it one by one. So let's begin with hemi-solid sphere. So center of mass of hemi-solid sphere. Now, as in case of hemi-solid sphere, mass is distributed over the entire volume of the sphere. So we are going to take volume mass density. So first we define its volume mass density. So rho would be m by 2 by 3 pi r cube. As this is hemi-solid sphere, so for entire solid sphere we know that the volume is 4 by 3 pi r cube. So for hemi-solid sphere this would be 2 by 3 pi r cube. So this comes to be 3m. So this comes to be 3m by 2 pi r cube, right? And let's take origin over here. This is x, this is y. Again, we can expect that center of mass would be lying somewhere here from symmetry, right, along y-axis somewhere here. But how to calculate element? So we are going to take an elemental disk over here and its volume has to be considered, right? So let's say radius of this disk is x and its center of mass, this elemental disk is lying at a distance of y from origin, right? So this differential volume would be how much? dV would be pi x square into dy. Pi x square is its surface area into dy is its thickness. This one is its thickness in the direction of y. This thickness is dy. So dV is pi x square dy and dm would be rho dV. That is rho pi x square into dy, right? Now coming to the definition, so y center of mass, that would be y cm of dm into dm by integral of dm. So this is y, as center of mass of this elemental disk is at a distance of y from origin. So this is y and dm is rho pi x square into dy by total mass. So this comes to be rho pi by m y x square dy. Now this entire function is in y, but this is in x square, right? So can we represent x in terms of y? The answer is yes. We have one geometrical advantage over here, that for different values of x and y, Pythagoras theorem will always hold. So that is x square plus y square is equal to r square. So from here we can write down x square to be r square minus y square. So putting this value over here, so rho pi by m, and this is y r square minus y square into dy. So this comes to be rho pi by m r square y dy minus y cube dy. Now how to find out the limits of this integration? So the first element will be formed here at a distance at origin, that is y is equal to 0, and the last elemental disk will be formed over here, that is at y is equal to r. So integrating it between 0 to r, so this comes to be rho pi by m, and this is r4 by 2 minus r4 by 4. Now putting the value of rho over here, so rho is how much? 3m by 2 pi r cube into pi by m and into r4 by 4. So this m is cancelled out. So this comes to be 3r by 8. So we can conclude that center of mass of hemi-solid sphere will be lying at a distance of 3r by 8 from origin. right? Simple. So this is center of mass of hemisolid sphere. Now we are going to deal with center of mass of solid cone. So in case of solid cone, again as mass is distributed in the volume of the body, so we are going to take volume mass density. So first we define, so this is center of mass of solid cone. So first we define, so this is our solid cone. We can take it like this, right? And let's say this is radius, and this is height, and this is my y direction. We have taken origin over here at the apex of the cone. So first we define our volume mass density. So rho would be how much? M by 1 by 3 pi r square h. As we know, the volume of a cone is 1 by 3 pi r square h, where r is the radius of this cone and h is the height of the cone. And again, of course, we can expect that center of mass would be lying in this particular line from symmetry. So this comes to be 3m by pi r square h. Now again we take elemental disk at a distance of y from origin, and thickness of this elemental disk is dy, and radius of this elemental disk is x. So this differential volume would be how much? Pi x square into dy, and differential mass of this differential volume, that would be rho dv, that is rho pi x square into dy, right? Now coming to the definition, ycm is ycm of dm into dm by integral of dm. So center of mass of this elemental disk is lying at a distance of y from origin, so this comes to be y, and dm will be how much? Rho pi x square into dy by total mass. So rho pi by m y x square dy. Now again, this is integration in dy. So can we express x in terms of y? So of course we can express x in terms of y using properties of similar triangles. We have these two triangles to be similar. This triangle and this triangle is similar to each other, right? So in that case, what we can write down, so from properties of similar triangle, this comes to be h by r, this by this is equal to y by x. So x can be written as r by h into y. Now putting this value over here, this comes to be rho pi by m, and y into this comes to be r square by h square y square dy. So taking out the constant terms out of the integration, so rho pi by m r square h square, and this is y cube dy. So again integration limit. So the first element will be formed at y is equal to 0, and the last element will be formed at y is equal to h. So integrating it between 0 to capital H and putting the value of rho from here, so this comes to be 3m by pi r square h into pi by m into r square by h square into h4 by 4. So this is cancelled out, it's also cancelled out. So this comes to be 3h by 4. So we can conclude that the center of mass will be lying at a distance of 3h by 4 from apex, or alternatively we also say that center of mass of this solid cone will be lying at a distance of h by 4 from its base, right? Simple. So this is it. So center of mass of hemi-solid sphere is at a distance of 3r/8 from its base, and center of mass of solid cone is at a distance of h/4 from its base. So I hope you liked my video. If you like my video, subscribe to my channel and hit the bell icon. Thank you for watching. Thank you so much.